Hello, so today we're going to be talking about work and energy of a toy car. And I had a toy car that if you pull it back and then let it go, it just starts pushing itself forward. And I thought that kind of worked like a spring. So, how I wanted to demonstrate it is that I pulled the car back and let it go in order to demonstrate elastic energy converting into kinetic energy, and after that conversion happens, it gets all of that energy is reduced over a distance due to the force of friction. And because of that, thought that it should be possible to find the spring constant. So far, you've been seeing the demonstration that I made with the toy car going on loop. Now I will show the simplified version with the two distances, the distance that the car was pulled back at, which is kind of like the distance away from the spring's equilibrium center, and then it was let go, and then after that the car reaches back to its equilibrium and continues after a set distance. Now, for givens and assumptions, I said I was given gravity since there is a force of friction that is making the car stop. So then for the for the distances, I just measured pullback distance to be 5.5 centimeters, and the car after it returned to the equilibrium position to have moved 22 centimeters. And the way I determined the coefficient of kinetic friction between the car's tires and the polished wood floor. So some assumptions that I made was the car's a particle, therefore I ignored the rotation of the tires. I also said that energy is conserved, so I assumed immediately after the car has returned to equilibrium that all energy has been converted into kinetic energy. And as I previously stated, that I wanted to treat the car like a spring since it got pulled back and it launches. Now, in order to solve this, use the principles of work and energy that state the kinetic energy plus the distance, the work of a spring minus the work done of friction is equal to the final kinetic energy. The 2 points that I chose for point 2 and 1 were point 2 was the final position where the vehicle stopped, and point 1 was the completely stretched back point. The car is at its complete energy, and then after it reaches its full equilibrium point, I assumed no energy was going to be lost, so all of that energy was converted into kinetic energy. So then from that point onward, all that energy was negatively worked on due to friction. So then that's how I came to the conclusion that the spring's work is going to be the maximum work from this situation. Now, given that spring constant, I can determine, no matter how far back I pull the car now, I should only need the distance I pulled that car back in order to determine how far it should go, or at least give me a good estimate, which that sounds fun. But I think that's all I have. Thank you for watching.